Hello everybody, welcome to episode number 8 of the BIVBlog, Benedict's IT video blog. My name is Benedict Stockerband and today I want to show you my very latest development I call the configuration demonstrator. So for once we talk hardware. And this epitome of masterful German engineering, over-engineering even, is basically what I've come up with last evening because I was playing around with a couple funny things and got this kind of as a side effect. Let's take a slightly closer look. So what we have here is a little PCB. Well, actually it's perf board because it's a prototype and demonstrates my tremendous soldering capabilities as well. But, well, until this goes into serious production, that'll have to do. First of all, what do we have here? An LED. Nice green, comfortable color. So that's probably gonna do something. The LED is accompanied by the series current limiting resistor, and there's a standard, industry standard, run-of-the-mill power connector here, basically a 2-pin 100mm header. And what you might expect, once you connect power to it, the LED turns on. Fantastic, isn't it? But that's not all to it. Now, as you see on board, there's also a microcontroller. So this thing is microcontroller driven. And not only that, which is already something that might make marketing very, very happy to hear. No, there's also the ripple reducing capacitor for the microcontroller here. And there's a programming header, the ISP header here, which is, wow, this cable is crappy, which is there to reprogram the microcontroller. So this thing is field programmable, and it's possible to have users do software updates. Wow, lots more buzzwords. And not only that, we also have a bank of 10 dip switches here. So this thing is fully user programmable. Isn't fantastic? And what you can do, this is software version 1.0. You can actually use the dip switches to configure how the LED blinks. Isn't that cool? And this isn't even all of it, because with our latest brand new beta software, which you can install through the ISP header, given a bit of a computer and some software for the computer, you can actually do even more with this. And that looks like this. You can even make this thing fully configurable. Now, at this point, it takes a moment to boot, of course, pretty much like any real computer. And not only that, once it's booted, okay, it's sort of wildly flickering means the configuration is inconsistent. So let's see if we can fix that. That should do something. Now we have to reboot. And again, we see the boot process at which the LED sort of slightly dims up and then dims down again. And after that has happened, and it's faster than booting a standard PC server, so this isn't all that bad. In this case, the LED turns properly off. Excellent. So we got the configuration right. What happens if we configure it differently? And I hope I don't make a mistake in the new configuration here. What will happen if we configure it properly, reboot it again by power cycling? Try that with a regular computer without properly shutting down. It takes a bit of time to boot, and then after some time, after it has booted, the LED turns on. Now, if that isn't top of the line technology here, I'm not a German technical guy, really. Okay, so much about our current prototype. We're currently working on some additional software capabilities, but that's a topic for a future episode. And I hope you still enjoyed this. We're also working on making this slightly smaller. I mean, this is just a prototype, so the goal is to put the microcontroller and the resistor and the capacitor and the dip switches right into the LED. Make it a bit more tedious, maybe more demanding to configure the LED properly, because the switches, well, they will have to get smaller, but I'm sure you'll find ways to handle that sort of problem. Now, if you think that I've gone completely nuts by now, and why I couldn't just, you know, take an LED, put a resistor on there and just put a 2-pin header on there, or buy a LED with built-in resistor and maybe built-in blinker, and just stuff it right into the connector, you're basically right. Except that the point here is that I've seen so many things built basically like this contraption, that when I was building the circuit for a different purpose, I just decided I might well use it for a little video. Now there are things that we want to be configurable. For example, about, I don't know, 15 years ago, I've been to some sort of demonstration of some sort of data center monitoring software. And at some point I came up with the question, yeah, but how do I make it check for, I don't even remember what it was, some, what I thought fairly basic stuff. How do I configure that? No, you don't configure that. We do a project and build some sort of extra check model for you. It's going to take half a year, cost you $1 billion or so, whatever. And I was just completely dumbfounded, because I thought, okay, if I have monitoring equipment and I can't really make a test for things that I think that are important, what's the entire use of this? But there are a number of other things where configuration is highly counterproductive. Probably the worst case of this that I've seen so far is, or that's widespread and I've seen so far, I should say, is ZIP, the session initiation protocol used for IP telephony. Just one example, because we've had that in a discussion a couple of days ago somewhere else. There are 3 different ways to signal touchstones, and if you want to make that work, first thing you have to figure out that they call it DTMF, dual tone multi-frequency, and not touchstone like everybody else. Fair enough. And ZIP has 3 different ways to transmit these, and you have not one such stupid device, but at least 2, and you have to configure them consistently to make this work. And the first time I ran into this, I had not 2 devices, but 3, 2 ZIP phones, different ZIP phones, and 1 sort of telephony system. And because the 2 ZIP phones supported different ways to do DTMF, and I couldn't just use one setting that worked for all 3 devices, I spent half a day or so to figure that out, which was rather annoying. Obviously, I mean, I still remember this. And even that is not really that bad, because the situation really gets bad when you have to fix some sort of problem on a production system and run into these problems at that point. So what I wanted to show with this obviously nonsensical thing, being configurable isn't always a good thing. And if you're developing any sort of gear. I hope you keep that in mind. And in case you wonder why I built this, you can, let's see, you can take off the dip switches. There you go. And use an IDC sort of connector, and then this little board gets you, well, one LED which is on board for some reason, gives you 10 I/O pins you can use to connect things to, for example, the ribbon cable and also stuff. Won't tell you the exact details of this because it's meant to be some sort of, not Christmas, but New Year's Eve surprise for some people. But that's the reason why I built it. In case you wonder why I did this with perf board, is because I needed it a small size. If I would have used just some quick strip board, put it as it fits thing, it would have been at least 4 times the size. And that would have been more difficult to hide. Okay. So much about configuration. And I hope you enjoyed this. If you want to discuss, if you want to get the layout files for this or the software I've been running on this, if you really want to play around with this sort of stuff, move over to the forum at www.stepladder-it.com/BIVBlog/8 in this time. Otherwise, I hope you enjoyed this. If you watched this on YouTube and liked it, give it a thumbs up. Otherwise, hopefully see you soon after Christmas. Okay, have a nice holiday. Bye.